Good morning, all. I, Dr. Ribhu Abhushan Panda from the Department of Electronics and Communication Engineering, Centurion University of Technology and Management, Odisha, wants to demonstrate you about microchip patch antenna design using HFSS software. So this is the layout of this HFSS software. Here you can see one icon HFSS. If you click this, there will be two things. You just have to click the upper part, that is only HFSS. So I have clicked that, and here you can see one three-dimensional window. After this three-dimensional window appears, we can proceed for the design. Unless and until this three-dimensional window is not there, then we cannot do any kind of design. So this is the three-dimensional window. Before you proceed, make sure that in the view these five options: status bar, project manager, message manager, properties and progress, all are checked. Then you can go for HFSS solution type. Make sure that it will be model. You can use terminal also, but make sure that these are the default things. Okay. Then you can go for HFSS and all other options are there. We can go one by one. Okay. So we have to design one microstrip patch antenna. So let me show you a poster. Here everything is included. There are some formulas of this microstrip patch antenna based upon which the length and the width is calculated. The center frequency or the resonant frequency we have taken 2.4 gigahertz, which can be applied for many applications like 2.4 gigahertz, WLAN, Wi-Fi, all those things. Okay. A material, substrate material, we have taken FR4 Epoxy, operating frequency 2.4 gigahertz, substrate height is 1.67. All the calculations have been done, and the cut feed we have taken. Different type of feeding techniques are there. Here the cut feed has been taken for proper impedance matching. So these are the calculations we have taken. So width we have taken 48 mm, and the length here we have taken 40 mm, but you can take 50 and 50 also. Okay, no problem. So let us consider this and let us do the design. So at first I have to draw the box. So if I move the cursor, you can see the values are changing. So better you press the tab key in the keyboard. So x I can write minus 24, x length I can write minus 20, y length I can write minus 24, and z I can write 0. Minus 20 minus 24 0. Dx you can write 40, dy you can write 48, dz 0.0. So this is the ground plane which has been created. Now you have to press Ctrl D. This Ctrl D should be pressed for the active view. So I will press Ctrl D. So this ground plane is created. So I can modify the attribute by clicking the upper part of this one. So here you can expand. The box one is written. Click. Here you can write GROU in the ground. Then go to edit, and you have to assign the copper material. So here you can write copper. Then you can give any color. No need to make it transparent. So click OK. So ground plane is created. Then we have to create the substrate. So I can draw the box. I can give minus 20, minus 24, 0.01, because at the top of this ground plane substrate will be there. Then press enter. Then dx will be 20, dy will be 24, dx will be 40, dy will be 48, dz will be 1.6. So here you have to assign the material FR4 epoxy. Before that, let me rename substrate, then go to edit, then go to FR4 epoxy, then any color you can assign. Here also you can check the dimensions whether it is alright or not. Here also you can check the dimensions whether it is alright or not. So this is the substrate which has been created. Now we have to create the patch. Already patch dimensions have been given. Width is 38, length is 29.4. Remember, length we are taking in x-axis, width we are taking in y-axis. So let me draw the box. So length we are taking in x-axis, so I can write this one minus 29.4 by 2. This one I can write minus 38 by 2, and z I can write 1.61. Then dx I can write 29.4, dy I can write 38, and dz I can write 0.01. So the patch is created. I can rename as patch. Material I can assign as copper. Then color I can assign any color. Then this patch is created. Now we have to create the cut. Okay, so here you can see the cut and the feed that we have to create. This should be created very carefully. So cut width should be 4 mm as the feed width is 3 mm. Length of the cut is 9 mm. These are the dimensions which we have to take into consideration. But this is not correct. Let us measure and let us see whether this one is correct or not, because sometimes what happens, the measurement values will be slightly different. So how can you measure? You have to measure this particular border point. So you can click on this measure, go to position, then you can see this particular border point. So here if I click, then it is showing 14.7. So it was correct. So 14.7 was correct. Okay, but directly don't put. First you confirm, then only you can put. Okay, so 14.7 was correct. So let us again draw. I can give this one as 14.7. Then y value I can give minus 2, and z value 1.61. Y value I can give minus 2, z value 1.61. Then dx minus 9, dy 4, and dz 0.01. So here the cut is created, so I can rename this cut. Material you can take copper, color any color you can assign. Okay, this cut is right. Now how you can subtract this one? Click on the patch, press control, click on cut, then right click, edit, boolean, then subtract. So here you can see this is subtract. So if you click blank part and tool part, then it will be okay. Okay, so this one is the cut. Now we have to draw the feet. How we can draw the feet? So same these dimensions. 14.7 minus 1.5, 1.61 minus 12, 3, 0.01. 14.7, 14.7 will be this point. So this point we have to take into consideration because the feed will be this one. So if you measure this point, this will be another point. So let us measure the position. This point is 20. So we should not take 14.7, we should take 20. So this will not be 14.7 because after the edge it should come, so it will be 20. So 20 we have to take into consideration. Okay. So the length will also be vary. So you can take length is minus 20 also, no problem, because at last we will unite this. So that will be taken into consideration. So here the length and the dimensions already we have calculated. So I can take this one is 20, then minus 1.5, 1.61, then dx is 10, sorry, 20, minus 20, sorry, minus 20, then dy is 3 and dz is 0.01. So dx, dy, dz value we have taken. So here the value has been taken. So this you can rename as seed. Material you can take copper. Then color you can take any color. That will be all. So this is the feed. But here you can see this is not united. So you can click on the patch. You can click on the feed. Then right click, edit, boolean, unite. So this has been united. Now you have to assign the port and you have to give the input signal to it. So I can rotate. So I can rotate it in minus x. So again I am showing I can rotate it minus x. Then I can change this to the YZ plane. I can change this to the YZ plane. So you can see grid is looking like this. Then I can draw a rectangle. Okay, I can draw a rectangle. Then I can draw a port like this. So I can give the position x is 20, y I can give that is minus 2, z I can give 0, then dx I can give 0, dy I can give 4, and dz I can give 1.61 or 62 I can give, so that it will entirely cover. Okay, so the port is created. You can zoom if you want. So I am zooming this port. Now how can you give the excitation to it? Click on this, right click, assign excitation. You can give wave port or lump port. I am giving lump port. So name you can give 1, full port impedance 50 on. Then here you can click on new line. You can move the cursor. Here you can see a triangle. Here you can see a triangle. Click on that. Then again one triangle will come. Click on that. So it will be defined. So next, then finish. How can you confirm? You can expand this. Go to the excitation. If you click on this one, the port will show. So the port has been defined. Okay. Now you can go to the orient and trimetric or dimetric you can click. Okay, press Ctrl D, then your patch antenna will be visible properly. Okay, you can rotate this, you can see all these things. Okay, so this patch antenna is designed up to this and input has been given, but you have to give one radiation. Okay, so you can go to the HFSS, then you can go to the model, create open region, create open region. So frequency you can give 2.4 gigahertz. This is the radiation boundary excitation. So this open region has been created. This open region has been created. Now you can go to HFSS, then analysis setup, add solution setup and go to advanced. So frequency you can give 2.4 gigahertz, maximum passes you can give 10 or you can give 15 also, no problem. Maximum delta S, keep as it is, click OK. Then after clicking OK, then it will show the sweep type, that is fast. You can start from 1 gigahertz or 1.4 gigahertz. You can end at 3.2 gigahertz or 3.6 gigahertz. So you can click. So this is the range of the frequency in which you can see the result. Click OK. Okay. Then you can go to the HFSS and you can click on this validation check. After the validation check, all these things are okay. Means after clicking the validation check, if all these things are showing like this green tick mark, then it is all right. Then you can go to HFSS, click on analyze all. If you click, it will ask to save the project. So I can save it, review microstrip patch antenna 1. So I can save like this. Then it will start the simulation. So here you can see the simulation. Okay. So after watching the simulation, okay, then you can see the complete progress. It is going for the progress or not, all these things it will show. Okay. So here you can see the progress. It will take some time and then the simulation will be over. And after that you can go for the result and you can find out all the results. So here you can see it is taking time. So meanwhile, let me show you the poster. And here you have to subtract. So right click, I am writing the procedure. Right click, edit, boolean, subtract. And then here you have to uh, unite. Okay, so you have to unite this one. So how can you write? Right click, edit, boolean, unite. So these two procedures you have to follow. So it will take some time. So here you can see number of passes. Generally, you have to give more so that it will converge and the result will be appropriate. Okay. So based upon the RAM size, based upon the uh, mm, based upon the efficiency of the computer, the simulation will go into the simulation will be over in a short span of time, or it will take some long time. Based upon this parameter, the simulation depends. So basically, these are the parameters which you have to take into consideration. Okay, so here you can see the length and the width, all these things have been calculated based upon these formulas. These formulas are very very important while designing this patch antenna. These formulas are very very really very very important. So what are the applications? So Wi-Fi, Bluetooth, IoT, ISM band, wireless LAN, all these are associated with this 2.4 gigahertz frequency. Okay, so this is the expected performance optimization we are not doing. Resonant frequency should be 2.4, return loss should be less than minus 20 dB. So let us see whether it is happening or not. It will take some time, and then it will simulation will be over. As I have given 15 number of passes, so the time will be more. You can take 6 passes or 10 passes also, no problem, but generally we are taking number of passes more so that the convergence will be good, means the result will be accurate. Okay, so here you can see there are ports. Okay, different modes are there. Here if you can expand, there will be excitation, it will show you the excitation. If you expand this one, it will show you the bound. Okay, so if you want to see all kind of things, then you can expand this and it will show. And based upon this microstrip patch antenna, you can go for different type of feeding techniques like coaxial cable feed. Then you can go for the line feed, simple line feed, aperture coupled feed, all those things. Generally in the DR, dielectric resonating antennas, these feeding aperture coupled feed, all these things are used. But generally for good impedance matching, we are coming for this cut feed. So here you can see the insert depth and the gap, it has been calculated, and there is also one formula to calculate this, or you can use any AI tool, okay, to calculate all these things. Nowadays AI integrated things are also available. Based upon this, all the dimensions will be calculated. So it will take some time, and then it will the simulation will be completed. Here you can see the progress. Based upon this progress, you can tell, based upon the size of the RAM, you can tell whether this will be completed in a short span of time, or it will take more time. Okay, so I am showing you the complete simulation, antenna design and simulation for 2.4 gigahertz application. Okay, so this is basically the antenna design, microstrip patch antenna, rectangular microstrip patch antenna for 2.4 gigahertz application. So I hope it will be completed very soon. So it is completed. So you can go for the results now. Okay, and you can see the result. Okay, so this is basically the microstrip patch antenna design and simulation. So let me go for the result. Let me show you again this particular thing. these things should be proper, then only the results will be appropriate. Okay, so you can go to HFSS results, create model solution data report, rectangular plot. Okay, then you can see S11 S parameter, it will be dB, keep as it is, then you click on the new report. So here you can see the antenna is simulating at 3.59, so nearly at 2.4 2.3691, so nearly at 2.4 gigahertz. So the result is appropriate. You can right click, add marker, then if you put this marker here, it will show you the value. So nearly it is 2.36, means nearly 2.4 gigahertz, and the return loss is minus 20.01. So we are getting this expected outcome, that is less than minus 20 dB we are getting. Resonance frequency nearly we are getting 2.4 gigahertz. So this is the S parameter you can take into consideration. Okay, then you can press escape, then you can go to the HFSS, then radiation, insert far field infinite sphere, then it will come infinite sphere 1, then you can write 0 to 360, 0 to 360, then 0 to 360 theta and phi value, then click OK. Okay, so this value you can give, then you can go to the HFSS and you can see the radiation also. So results, far field report, radiation pattern. So you can see the radiation pattern, but here in the geometry you have to change infinite sphere. Okay, then gain is there, so you can click on the dB, then you can click new report. So here you can see the radiation pattern. Now you can also see that this is the 2D radiation pattern. Some back lobes are there. This back lobe should be emitted. So research number of research can be made to emit this. Then you can go for the result, far field report. Then 3D polar plot. You can go and you can again go for the infinite sphere, gain, dB, then new report. So this is the 3D polar plot. Okay, so these are the plots you can take. So you can click on the save, so it will be saved. Okay, now here you can click to integrate that particular radiation pattern here, how the antenna is radiating and the radiation pattern here. You can click on this patch and right click, plot field, then radiating field, then it will show. Again I am showing, click on the patch, right click, plot field, then radiation field, then it will show the two plots. So you can click on the 3D plot, so here it is written 3D, so you can click visible and apply. So here you can see the 3D plot also. Okay, if you click on the scale 1, it will be more. If you click on the scale 0.5, it will be half of that. So you can change and you can see. So transparency, you can make it more transparent. I am giving it 0.8. So this is the antenna you have designed. So this is how the antenna is radiating. So number of research is going on, how to reduce this back lobe, all these things. So you can go for many papers, you can read journal articles, conference articles, and you can do very nice designs in this HFSS software. So thank you all of you. Thank you. So I hope you have understood this uh, antenna design using HFSS. So I would like to thank each and everyone for watching this video. If you like this video, then please like, share and subscribe to my channel. Thank you all. Thank you.